In this math counts preparation lesson, we're going to be exploring some LCM and GCD problems. We're going to start here on the 2020 Math Counts School Sprint Round number 24. If n is an integer for which the greatest common factor of n and 18 is 6, so we have the GCF of n and 18 is 6, and the least common multiple of n and 9 is 126, what is the value of n? So we're given all this information, we're asked to find the value of n. So I'm going to write down our information first off. We know the greatest common divisor, same thing as greatest common factor, of n and 18 equals 6. And then we know the least common multiple of n and 9 is 126. I'm going to start off by listing out the factors of 18, so I can get a feel for the possible values of n when we're just focusing on the GCF of n and 18. So 18, 1 is a factor, of course, 2, 3, 4 is not, 5 is not, 6 is, 3 times 6 is 18, so now we go from here, 2 times 9 is 18, and then we have 18. So these are all the factors of 18. And we want the greatest common factor of n and 18 to be 6. So there's 6 right here. Now, what we can't have is a multiple of 9 or a multiple of 18. Now, every multiple of 18 is a multiple of 9, so long story short, we cannot have a multiple of 9. Now, let's check out multiples of 18. Multiples of 18, well, the prime factorization of 18 is just, well, we have 18 is 2 times 9, and then we have 2 is prime, and then we have 3 times 3 is 9, so we have 3 squared times 2, and when we expand this, 3 squared times 2, we're going to get 9 times 2, which is 18. So basically we can't have a multiple of 9. We can't have an even multiple of 9. So no even multiples of 9. That can be n. Okay, so basically our strategy here is going to be, we're going to find out what's easier. Either the LCM or the GCD. We've already done a little bit on the GCD side. I'm going to go back to the LCM side, see if that makes things easier. The least common multiple of n and 9 is 126. Now, I like to take LCM using prime factorization because it helps me figure how to get my product. So over here, the prime factorization of 9 is 3 squared. And n, we need n to have some factors. Well, right away, 9 appears twice over here. So we have at least a 3 squared. Now, this thing builds a 9. Now, 126 divided by 9, well, I'm just going to do the division out. I know I'm going to have a 9 over here, and then I'm going to have a 3 over there because I subtract off the, because I have a 9 over here, 12 minus 9 is 3, 36, we have 14. So I know I need factors that have a product of 14. Now let's explore 14. 14 has factors of 2 and 7. 14 has factors of 2 and 7, so then I need a factor of 2 and 7. Now, while I have this over here, I'm going to go back to the GCD, because the GCD is easier to handle. All we need to do is go up the multiples of 6 and hit one of the multiples of 6. So I'm going to go up the multiples of 6. We already know we're going to start off with the fourth multiple of 6, since 18 is the third multiple of 6. So 6 times 3 is 18. 6 times 4 is 24. The greatest common divisor of 24 and 18 is 6. So 24 is a possible value. It's a possible value of n. But it's not really, like, it's a possible value right now, but we can easily prove it wrong. So let's try to prove it right. Let's try to prove it wrong, since if it's proven wrong, we can just move on. LCM of 24 and 9. Well, I know this is not going to be true because 24 times 5 is 120. And so 126 is not even a multiple of 24, so we can just go ahead. 6 times 5 is 30. 126, not clearly not a multiple of 30. We can move on. So 6 times 5, 6 times 6 is 36. So 36 and 126. Well, 36 times 6 is 216. And 36 times 4... Well, I'm going to go 36 times 3, which gives me a units digit of 8. And 36 times 3, well, 30 times 3 gives me 90. 30 times 4 gives me 120. And 36, no. So 36 can't be a case. It is a case. And 36 we can just avoid because it's an even multiple of 9. So avoid that. Now, 6 times 7 is 42. Now, 42, it matches up with this. So we can test out 42 over here. 42 and 126. That actually might work. I'm going to write it down since I see that 42 times 3 gives me a unit digit of 6. And 4 times 3 is 12. Let's check this out. The factors of 42 is 1, 2, 3, 6, and 7. And from here, we have 14. 3 times 14 is 42, 21, and 42. Let's check it out. The GCD, or GCF, whatever you want to call it, is still 6. So it satisfies this over here. Now let's check out the LCM. Let's check out the LCM. Let's place in the n as 42, since I'm confident it might be over here. The prime factorization of 42. Well, I'm just going to use we'll need a 6 and a 7, since 7 is prime and it's easy to break up 6 into a product of primes. So I have 3 and 2. Now I have 3 times 2 times 7. 6 times 42. Now, the only cases we have are 3, 2, and 7. Well, over here, what we have is 3 appears twice, so we have 3 squared. Over here, that's already the case. And over here, in 42, we have 3 times 2 times 7. Don't forget that. We have 3 squared, and then 2, and then a 7. And, well, 3 squared is 9, 2 times 7 is 14, 14 times 9, we already know that product. That brings to 126, so we conclude that the LCM is also 126. It satisfies both conditions, so that means we found our number. It is 42. Once again, always break your problem into 2 parts. We have GCD over here. LCM was all going on over here. In this problem, GCD was way easier than the LCM because LCM is a little bit scary.